In this episode, we will be implementing the ability to rotate wheels into our interaction system. This will work very similar to the Switch, where the percentage of the wheel turn is used to affect some node in the scene in real time. This should make puzzle solving and interacting with the environment in your game feel alive, while also still being intuitive to the player. As always, be sure to stick around till the end of the video because we will refactor our code to remove some bugs. Alright, welcome back to the super awesome immersive simulation controller that we are building in Godot. If you have not seen the previous episodes, you should probably go watch them because we are building off of an existing interaction controller and component system that we built from scratch. But if you just want to learn how to turn a wheel, you can probably figure out the logic as well. So let's go ahead and get started. So to get started, we're going to affect our sandbox a little bit. So I'm going to go ahead and add another node 3D, and I'm just going to call this, we'll call this floor 2. And what we're going to go ahead and do is just copy floor 1 and paste it as floor 2. And floor 2 is just going to be dragged somewhere, what is this, 1, so we'll drag this somewhere over there. Now what we're going to do is we are going to create a little drawbridge that is completely vertical, and as we turn a wheel, the drawbridge will lower and allow us to cross. So let's go ahead and create that drawbridge. Very simply, we're just going to go ahead and do a CSG box and drag that back over here, and let's go ahead and get this level with the floor. Maybe right about minus 0.5, and make sure that's right at, minus 35, minus 36, minus 35.5. All right, and we're going to go ahead and make this a little bit wider, and then we also want to drag it the length of the distance between the two floors. So let's go ahead and rename this to be the bridge. Now, similar to the way we handled the doors, if we try to rotate the bridge, you can see that it's just going to move in on itself. So what we need to do is under floor 2, we need to add a node 3D, and we're just going to call this our pivot point, and put the, actually before we do that, we're going to take the pivot point and make sure that it is sitting right here. Make sure it's right level with the ground. So go ahead and go into the transform and make these nice round numbers. Minus 0.5, excuse you. And so now when we want to rotate the bridge, drag the bridge onto the pivot point, and we are going to rotate the pivot point so that way it can end nice and flush with the floor on the other end. Now we're also going to go ahead and grab this podium here, and we don't want the switch on it, we just want the static body. So go ahead and copy that, and under floor, well, we can just paste it under the sandbox. Paste it over here. Make sure we kind of drag it into place here. And we can go ahead and change the label text to say rotate. And we should probably put this under its own node 3D, which we will just call podium 2. Keep it simple. Pull that out and drag your static body onto that. All right. So now we have the foundation of our environment set up. We have our bridge set up so that way we can rotate the pivot point. Let's go ahead and build ourselves a wheel. So to build ourselves a wheel, we're going to start a new 3D scene. We are going to make sure that this is also a static body 3D, which we are just going to call wheel. And let's go ahead and add a mesh instance 3D, and that's also going to get a collision shape 3D. And the way we're going to build our mesh is we are going to make it kind of look like a stick. So we kind of did this with the switch. So let's go ahead and add a new box mesh. Let's make the X value point, let's go ahead and leave that, let's make that 0.5. We'll make the Z value 0.1, and then we'll make the Y 1.5. Let's go ahead and make this a little smaller. It's something like 0.2. So we're going to build a wheel that has spokes. So let's go ahead and do that exact same shape for the box. 0.2, 1.5, and I believe it was 0.1 maybe. Maybe 1.5 is too tall. Let's make this 1 for the collision shape and the mesh instance. And I think that's too thick. Let's just make it like we did the switch. So there's our first spoke, and this specific spoke we are going to want to put a surface material override on so that way it has a color. So we're just going to do standard And in the albedo, I'm just going to make this gold, just like that. So now go ahead and copy both the mesh instance and the collision shape and paste them under wheel. So that way you have 2 and 3. So we're just going to take 2 and we're going to put it at a 45 this way, collision shape 45 this way. Take this mesh instance and put it a 45 the other way, as well as its collision shape. And we want to go ahead and remove the surface material override. Just, where is clear? There it is. So here's kind of what our wheel is going to look like. We're also going to want to add a in between. So let's add another mesh instance. This mesh instance is going to be a cylinder mesh. We're going to turn it 90 degrees, and we are going to make it, I believe it's 0.1 meters. And we need the radius to be a little bit smaller, so we'll say 0.3 and 0.3. So there we go. So now we have a little wheel. This is going to need a collision shape, so we're just going to hit create collision shape, and that's fine. This is just a demonstration. So essentially what we've done is we've created a wheel, and we're going to interact with these collision shapes, but I specifically wanted this one to be gold, so that way as we turn the wheel, it should be very easy to see where we started and where we stopped. And just to fill this out, I'm going to go ahead and grab another set of the mesh instance in the collision shape and just put it between those. There we go. That looks a little more well-rounded. So there's our wheel. Now all we need to do is, once again, go into our interaction component and drag and drop it onto the wheel. So we're going to have to set this up in the code. So let's go ahead and save it under our objects as a wheel. Let's go ahead and enter the interaction component script and think about what variables we are going to need to modify. So the first thing we need to do is add the wheel type to our interaction script. We need to rotate our wheel, but luckily we already have the ability to define the maximum rotation. We want our wheel to affect the drawbridge, and we already have the ability to affect nodes in the environment. But we are going to need some more references, specifically to where our mouse location is at any given frame. So the wheel is going to be a little more complicated of an implementation, but I promise I'll explain it the best I can as we go. So let's go ahead and add a variable for a reference to the camera. So we'll just say var camera, which is going to be the player's camera 3D. And then we're also going to need a reference to the mouse position, which we are going to call the previous mouse position. And this is a vector 2 representing where we are in the X and Y on the screen. We're also going to want to keep track of the wheel's rotation, which is going to be a float, which we can just set equal to 0 for now. All right, and in our interaction script, in our ready function, we need a new interaction type, which is going to be the wheel type. Now, once again, we need to do the same calculation that we did for the switch. We need to know which axis we're on. In fact, it may be smart to rename this switch on X-axis and change it to something better. So we'll just say axis of change. Now, that doesn't make a whole lot of sense, but it'll work now. So let's go ahead and update our script to use those. So similar to the switch, we need to know the rotation that we are starting the wheel at, and we need to know the maximum possible rotation. So now down in our pre-interact, which runs once when we first click on the wheel, we are once again going to need a interaction type defined for the wheel. We want to lock the camera for the wheel as well, since we will be spinning our mouse around. But we are going to need some new variables. So let's check that out. So the first thing we need to define is where the mouse is. So the previous mouse position is just going to record where the mouse is, and in this specific instance, in the pre-interact function, this is where the mouse is when we first click on the wheel. So get our viewport and just get the mouse position and store that. Now the other thing we want to do is we want to expose our mouse so that way we can see it. And the reason we want to do that is because how we are going to move the wheel is we are going to move our mouse around the center of the wheel. So let's go ahead and look at that in 3D space. So the way this is going to work is I'm going to click on the wheel and I'm going to move around the center of the wheel to move it. In games like Five Nights at Freddy's: The Secret of the Mimic,
the player has arms and will actually grip the wheel and spin in real time. And that's kind of how the player would know where they are spinning. Since we don't have arms in this demo, we are just going to show the mouse so that way the player can see which direction they're spinning the wheel. And by default, we captured the mouse when the player script hits the ready, and we set that to be captured. So essentially, in the interaction component, we are just unsetting that. And that, of course, means that in the post interact, which runs when we are done interacting with an object, which is here, we need to set this back from visible back to captured. So now let's go ahead and look at our input function, which is where our logic is going to be held for moving the wheel. So just as before, we're going to need a new clause for if our interaction type is a wheel. And if it is, we still need to check to ensure that this is a mouse motion. So if we are moving the mouse and this is a wheel, what are we going to do? Well, we need to keep track of the mouse position. And to do that, we just call event.position. And this will tell us where something is happening on the screen. And in this case, it's just where the cursor is. So I'm going to go ahead and pull up Paint so that way I can explain the math calculation we're about to make. So here we are in Paint. And if you can imagine a wheel spinning like this, there are two ways we can spin the wheel. We can spin it counterclockwise, or we can spin it, clockwise. Now, spinning it clockwise should lower the bridge, and spinning it counterclockwise should raise the bridge. But the problem is we are performing our input functionality on a frame-by-frame basis. So how do we know which way the mouse is moving? Well, we have to keep track of where it was previously. So if on the previous frame the mouse was here, if the mouse on the next frame is here, if the mouse on the next frame is here, you can start to piece together which way the wheel should be spinning. But we need to do a bit of math to actually fully calculate that. So essentially, we need to know where the center of the wheel is. So if we know where the center of the wheel is, and on this frame, on the first frame, I guess I should say, the mouse is here, and then on the next frame, the mouse is here, we can do some math to calculate that this line is going up and to the left. And that should tell us that relative to the center, we are doing a counterclockwise motion. So the math may seem a little complicated, but all we're doing is keeping track of where the mouse positions are and if they are going counterclockwise or if they are going clockwise. So let's get back to the code. All right, and for this math calculation, we're going to go ahead and create a separate function for it. So let's go down to the bottom of our script and create a function. And this is actually going to be called calculate the cross product, because that is the mathematic term for what we're actually solving for. So what we need is we need our mouse position, which we just got, and that's what we're going to go ahead and pass into this. And this is going to go ahead and return a float value. So what do we need to know? Well, the first thing we need to know is where is the center of our screen. So let's grab our center position. And the way we're going to get this is by using the player camera. So let's get the camera. We want to do unproject position, and we need to use a reference to the object and to get its global transform dot origin. So that seems like a lot to be happening, but essentially, where is our wheel? We want to make sure that the wheel is the center of our spin. So if I'm over here and I click on the wheel, I don't want to be spinning around the center of my screen because that doesn't really make any sense. We want the player to be spinning around the center of the wheel, no matter where the player is looking at it. You know, they could be above it, below it, as long as they're in reach. It makes the most sense visually to spin around the wheel. So we need to use our camera and kind of unpackage where we are on the screen and where the wheel is in the world relative to where our screen is. I'm also now realizing that we never actually added our reference to our player camera. So we're going to go ahead and do that in our ready function. We're just going to say that our camera is equal to, and we're just going to copy the pivot point logic. we're going to get the tree, get the current scene, find the child, and we named that camera 3D. So if you look in your player, if you change the name of your camera 3D and access it as a unique name, make sure that this is accurate. So now that we know where our camera is, let's continue on with our calculation. So the next thing we need to know is our vector to previous meaning our mouse position. And we calculate that by getting our previous mouse position and subtracting out our center position. So this is a reference, if this is our previous and this is our current mouse position, we are calculating the line right here. Now the next thing we need to know is the vector to current, which is obviously our current mouse position, which we are passing into this function, subtracting away our center position. And as you can guess, that is this line right here. So now that we know those two values, we can go ahead and calculate the cross product. So the cross product is just our vector to current, x value, times our vector to previous, y value, subtracting away our vector to previous, y, times our vector to previous, that is a space instead of an underscore, vector to previous x. And then of course we want to return this cross product value. Now this cross product value is just a float, but this is going to tell us whether or not we are moving clockwise or counterclockwise. So if this calculation comes back negative, we are going to be moving counterclockwise. If it comes back positive, we will be moving clockwise. So let's go ahead and call this function and keep going with our wheel functionality. So let's go ahead and go back up to our input function up here, and let's go ahead and call this calculate cross product. So what we want to do is we want to calculate cross product using our mouse position. And so we want to check if that is a negative or a positive value. So if that is a positive value, then we want to increase our wheel rotation by a certain amount. Let's just hard code 2 for now. And if it's negative, we want to decrease our wheel's rotation. In other words, we want to turn the opposite direction. And 2.0 is going to be very fast. I think I meant to do 0.2. We don't want to be moving too quickly. So now that we know the wheel's rotation, we're going to have to perform the same check we did for the switch to know if our wheel is on the x-axis or the z-axis. So if we are on the axis of change being an x, then we want our object reference dot rotation dot x to be equal to our wheel rotation times 0.1. Now, once again, we don't want to overspin or underspin, so we need to take our object reference dot rotation dot x, and we're going to have to clamp that value. So object ref dot rotation dot x. And we want to clamp that between our starting rotation and our maximum rotation. And we also want to, well, we can do that outside of this. So if we want to do this on the z-axis, we're going to do the exact same logic. So now that we've spun our wheel, we need to make sure we update our mouse position to be the current one. So that way it is ready for the next frame. We need to calculate the percentage. So this is actually the same exact calculation as the previous input of the switch. So once again, we're going to want to grab that percentage float, and then we're going to want to grab the calculation and make sure that it's done either on the z rotation or the x rotation. Okay. And so now that we know the percentage that the wheel has spun, we are once again just going to call our notify nodes and update them with a certain percentage. And that should be all the logic we need to get the wheel to spin. So at the end of the video here, let's do a little bit of refactoring. Now, if you have been following the tutorial series from start to finish, you will have already done this refactor in the switch video. And it has to do with the axis of change boolean that we attached to our interaction component. So we were using this axis of change to know if we needed to rotate the wheel and or switches on the z-axis or on the x-axis, because obviously you don't want the wheel to be rotating like this. However, we don't actually need to have that boolean anymore because we can fix that and use local rotations and not have to deal with the extra logic that comes along with it. This will simplify our interaction component and make things easier for you. To fix this, all we're going to go and do is enter your script. Now, like I said, if you have already done this in the switch video, you won't have this boolean, but make sure you remove the axis of change boolean here. Go ahead and scroll down, and you'll see that we have this check. Now, you just want to keep the object rotation Z. We don't care about the X, so get rid of that if, else if, and make sure it's just one line for the starting rotation. Go ahead and come down to where we do our actual logic for the wheel movement and do the same thing. Remove the if, else. So now go into your wheel. I'll go back into 3D view, and all we need to do now is left click on the wheel, hit Control A and add a node 3D. I'm going to rename this to wheel. And I'm actually going to make sure that this is capital W. Right click on it and make scene root. So since we have access to the wheel's object reference, what we'll actually be doing in the code is rotating the wheel on the z-axis always. However, since we now have this node 3D, we will be using the top level node 3D to move it around in world space. So to demonstrate that this works, we're going to go ahead and go into our sandbox and modify this podium to get it to face a different way. So to do that, I'm just going to come into my scene tree, and I'm going to go ahead and delete this wheel. I'm going to drag our newly updated wheel onto podium 2 and just get it into place. All right, so there's our wheel. Now we're just going to go ahead and copy the entirety of podium 2 here, and we're going to rotate it in a different way. So Control C, Control V. We're going to go ahead and reset its transform, pull it out here, and spin it around this way. So there you go. So now we have two wheels facing one on the x-axis and one on the z-axis, but they should both rotate the same. So let's go ahead and run the game. Let's run over to our wheel. Here's our first one. You can see it's spinning correctly on the z-axis, and we grab this guy, and it is also spinning correctly on the z-axis. And this works because now that we have, let's go ahead and make this local. This works because we are moving the whole node in world space, but we're only rotating the object reference, the static body, locally. So that allows us to refactor our interaction component and simplify it such that it doesn't need that unnecessary boolean. We want to assign the object reference to our wheel. This interaction type is a wheel. Now the maximum rotation is actually going to be any kind of spin ratio. So we don't want it to be 90. 180 would flip it halfway, and I actually want to rotate completely around. So we're going to do 360, and we're going to set the nodes we want to affect in the sandbox. So let's go ahead and add that in there. So in our sandbox, here's our podium to rotate. We're going to grab our object, and we are going to grab our wheel. And wherever podium 2 is, we are going to drag our wheel onto that. We're going to raise it up and turn it 90 degrees and pull it up to roughly about there. I think that looks all right. Now let's go ahead and take the bridge and, we want to grab the pivot point and we want to rotate that 90 degrees. So the bridge is not up, and we want to spin the wheel to lower the bridge. So let's look at our wheel, make local. And let's look at the interaction component. Oh, sorry, that's not what we want to do. We just want to go in the sandbox, click on it, and make sure that this is set up correctly. Wheel 360 degrees. That looks correct to me. Now we just need to add an element to our nodes to affect and assign our bridge value. But we also want to assign the pivot point because that's what we actually want to spin. So let's go ahead and click OK. Now, the last thing we need is we actually need a script on the bridge here. So that way, when we rotate the wheel, this listens, similar to the way we wrote a simple script for the light. So let's go ahead and do that. So we're going to go ahead and click on the bridge and add a new script. And in our scripts folder, we can just call it bridge.gd, and we'll go ahead and create that. So we need to know two things about our bridge. We need to know the starting rotation, and we are going to want to know how far the bridge has to rotate. Now, the reason we are defining these on the bridge instead of in the interaction component is that we may want the bridge to rotate a different amount than the wheel, and that's actually true in this case. While we want the wheel to have to spin a full 360 degrees, we only want the bridge to go down 90 degrees. I don't want it to do a full 360. So we need to make sure that the rotations are relative to what we're spinning. So let's go ahead and go back to that script. And so in the ready function, we need to assign our starting rotation to be our rotation on the x-axis. Actually, we are going to need to know which axis. No, we actually do know that this is going to spin on the x-axis. So that's fine. So now that we know that the starting rotation is x, we also need to calculate the final rotation. And this is going to look similar to the way we did it for all of the calculations in the interaction component. Radians 2 degrees. This is going to be the starting rotation plus the final rotation. And so that, final rotation equals this, yes. And so this is going to set up how we want the bridge to turn and function. So now we just need to add our execute method that the nodes to effect function is going to call. We need to know the percentage, which is a float, and return void. And this calculation is going to be a little interesting, and I'll explain how it's working once it's done. So once again, we are affecting the rotation of x. That is equal to the starting rotation plus the percentage in which we've moved. But of course, that's multiplied by the final rotation minus our starting rotation. So what does this show us? So the final rotation minus the starting rotation is going to show us how far in the process we are of lowering the bridge on a degrees level, whereas the percentage is going to show that in a decimal or, a percentage level. And so we need to multiply these to get a certain value, add the starting rotation. So for instance, the starting rotation of our bridge is 90 degrees. Actually, I think it's technically 0 degrees. So the starting rotation is 0 degrees, and when it's down, it's 90 degrees. So if we go back into our script, we would have percentage times 90 minus 0, so 90. And then our starting rotation is 0 plus the percentage times 90, which means that if the bridge was at 60% down or so, then we are going to want our bridge to be around 55-ish degrees, because the percentage is not going to equal the total degrees, because our total movement is 90 degrees. However, our total percentage is 100. So that little difference is where this calculation needs to happen. So let's go ahead and double check our work and see if this bridge will turn. So double checking our work, I actually see a mistake I made. This interaction type needs to be a wheel. So let's go ahead and test and see what our wheel does. So if I go over to my wheel, I click on it, the mouse is now visible. And if I spin it, you can see it's actually spinning the wrong way. So that's one problem. And the other problem is that the bridge is not actually lowering. So let's go ahead and fix those. The first one here is that the interaction component should be less than, and that will actually spin the wheel the correct way. Now, the second problem is that we are trying to rotate the bridge when the whole reason we created the pivot point was to rotate the pivot point. So let's go ahead and detach the script from the bridge and put that on the pivot point. So if we go ahead and save and look at our bridge script, we now have a different starting rotation. And we need to make sure that this is reflected within the interaction component. So you can see here we were already affecting the pivot point, but the script was on the bridge. So now that the script is on the pivot point and we are trying to affect the pivot point, this should work. So let's go ahead and test and find out. And I've actually just got an error because this is no longer on a CSG box, so make sure you just change that to Node 3D. That was also incorrect because our cross product was wrong. You see, we should be multiplying our vector to current y value times x. And so now that that's fixed, one thing I also did notice when I was clicking on the bridge is that I didn't use collision. Now that's kind of the problem with just using CSGs, is that unless you are copy and pasting from the first one with using collision, they won't have it set. Walking over to our bridge, we can see we can turn to the right and the bridge will lower. And if we turn to the left, the bridge will raise. Now it is worth noting that you do have to spin around the center of the wheel. So if I grab the wheel and I move my mouse up here and spin, nothing's going to happen. The bridge is just going to kind of sit there. But now that it's down and we have collision enabled, the player is now able to walk across the drawbridge, and now they're able to walk across back. So there you go. You now have a working drawbridge wheel as a part of our interaction component and our interaction controller. So hopefully you can combine all of these to make some fun puzzles. And if there are any ways you think I can improve this controller, go ahead and leave them in a comment down below. I do plan on doing a whole refactor of this whole project, and I would love to be able to take some viewer suggestions and add them into that video. So the next implementation is going to be collectibles. So while it has been fun to be able to pick up boxes, flip switches, rotate wheels, and open doors, the player is going to want to be able to pick things up and put them in an inventory. Now we're not going to do the inventory right away, but picking up items is the next thing on the menu. So I will see you all in the next one.